All right, last section is 3.4. Looks something like this. We actually get to somewhat skip over the top part because we have talked about reference angles in 3.1. Just recall that it is an acute angle formed by the terminal side and the horizontal axis, also known as the x-axis. Okay. There are your little tricks on how to find that reference angle if needed. But I'm not going to spend a lot of time on that. So we're going to look at two different examples. The first example is if I gave you the point -1, 1. So -1, 1 would be, just making that up, right? Could you tell me the exact values for sine, cosine, and tangent? And after today, your answer is going to be yes. Yes, I can. Okay, and here's why. So -1, 1 puts me in quadrant 2. That's important to note. Okay. That draws me a little right triangle with the one of the lines on the horizontal axis. Make sure to do that. Sometimes to help people remember, I tell them that the triangle must draw a bow tie. Like those are the only 4 triangles you can have. You can have, fatter triangles, skinnier triangles, whatever, but they still need to look like a piece of a bow tie. All right. And then I know that the x value is -1 and the y value is 1. Recall your geometry skills. A squared plus b squared equals c squared for all right triangles, which this is. So I have -1 squared plus -1 squared equals c squared. Oops, one of those should be positive. Sorry, they're not both negative. Doesn't really matter for our next step if you've been working ahead, because once I square it, it gets 1 plus 1. That is 2. Take the square root so that c is the square root of 2. Okay. Now that I know all of the sides, and I think about this being the angle I'm finding, so the angle formed with the origin there, this is opposite, adjacent, and hypotenuse. So if sine is opposite over hypotenuse, I get this, which will simplify to square root of 2 over 2. That's rationalizing. See the previous video if you need some examples of rationalizing. Cosine would be the x value, so -1, over the hypotenuse. Same idea there, rationalizing. That is negative square root of 2 over 2. And tangent is opposite over adjacent, which is just -1. Cosecant is the reciprocal. Remember, it's much easier to take the reciprocal of the first one than it is the second one, because the second one would require me to rationalize yet again. Reciprocal here just becomes square root of 2 over -1. Well, a positive divided by a negative just makes it negative overall. And then the reciprocal of -1 is still just -1. So not too bad. We just have to think about it using things that we already know. Okay. All right. As far as our quadrants go, I have a little memory trick. It's a false statement, but we're going to go with it. So all students take calculus. And we start in the first quadrant. So notice I have the A, the S, the T, and the C. And we work our way around. And what it's there to help us for is to note that everything in quadrant 1 is positive, hence the A. Only sine and its reciprocal, so sine and cosecant, are positive in quadrant 2. In quadrant 3, only tangent and its reciprocal, which is cotangent, is positive. And then in quadrant 4, only cosine is positive. So you're like, what are you talking about, Ms. Reidner? Well, let's take a look. Tangent is positive in this example because the answer to tangent is 3/11. Looking at my little blue bow tie up here, tangent is positive in quadrant 1 because everything is, or quadrant 3 because just tangent is. All right, so I've got it narrowed down, 1 or 3, 1 or 3. Let's look at our second piece of information. Cosine theta is greater than 0. So cosine theta is positive if it's greater than 0. So out of our options 1 and 3, which one of those is cosine positive? Well, it has to be the one where all is positive, because if I have two things positive, it automatically puts it in quadrant 1. So my triangle belongs in quadrant 1. Not the best triangle I ever drew, but there we go. Tangent is opposite over adjacent. I can use that information by doing a squared plus b squared equals c squared. So that is 9 plus 121 equals c squared. So that's 130 equals c squared. So I have the square root of 130 equals c. So that is the square root of 130. Now, I'm ready. Sorry, lots of words. Now I am right back to the last example. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent. We already have tangent. If you missed that one, you miss out because it's right there. Okay. Let's see. I'm going to go ahead and fill in cosecant because the reciprocal there is much nicer. Same here. And cotangent reciprocal is nice. So before I finish this video, I'm going to write my answers rationalized because notice my sine and cosine have it in the denominator. We don't like that. So it becomes 3 square root of 130 over 130. And then 11 square root of 130 over 130. And I have completed it. Make sure to try some practice problems before going straight to that mastery check because this is something that requires some practice.